70 amps there.
Yeah.
When you're welding.
Now, I've done a big no-no here, but since this is just a demonstration, I didn't take all the time that's needed to prep my material. So I just want to make sure you all know that. Because you're looking at this going, you got purple and blue in there, and that's right, I do. Why? Because I did not clean my titanium the way I should have. Yes, I have an inert atmosphere here, but my titanium is dirty. Got fingerprints on it, got the dirt on there, so that's all being absorbed into the titanium. That's why you're seeing the blue and the purple, and on the outer part of the weld there, you're seeing even white. Right here, you see all that white? That's all rejectable. If this was an aircraft part, I'd have to get rid of it. Just waste it. I just wasted a bunch of titanium. But for demonstration purposes, I can show you, even though I'm in an inert atmosphere, that if you don't clean your base material, you don't take the time to clean your filler rods, you're still going to get contaminated metal. Now, how do I know my atmosphere is clean in here? Anybody want to guess?
I can't tell.
There's two ways to do it. Companies that do this all the time will have an oxygen meter they hook up to this. And you want like 50 parts per million of oxygen or less in your chamber. We don't have that, so we go the cheap way or the old school way. You take a piece of scrap titanium, strike an arc on it, and then you pull your torch away really quickly because you don't want the gas from here giving you any protection. You want to see if the atmosphere is good in here. So we strike the arc, watch your eyes, here we go. Get the metal melted, move the torch away, and then let it cool in the atmosphere. And you should have a nice silver weld there. Then when we turn it over, you should have a nice silver weld on. That tells the atmosphere in here is good, ready to weld in. Clean everything before. Everything gets cleaned before you put it in. You clean your tools. With acetone, this is not a good tool for it. You got paint. So if that was to get hot, that's going to put hydrogen off. Clean all your parts. You wire brush them down to they're really shiny silver. And you wash them off with acetone. As you can see, I did not do that here. I'm trying to just do demos to show you what does happen. On the back, I'm getting nice silver there where I did get the penetration there. That's how critical titanium is. It will absorb the oxygen, hydrogen, nitrogen once it gets above 600 and get contaminated.
Do you need to run the oversized gas engine? I mean, is there a reason why you have to run oversized?
I'm just showing you this different systems here, and Conley and Pepin was kind enough to donate all of this equipment to me, the chamber and these for demonstration.
Would you normally weld with an oversized gas lens?
In here, no. What I normally in here, I use a gas lens, but I usually either use the standard glass size, or I'll use a regular ceramic cup.
Okay.
You don't have to. I can take this cup off and weld in here. Now what I just exposed myself to is, if I'm doing an intricate part, say like that T-joint there, and I touch this collet to the metal, I just short-circuited, I A, ruined my gas lens, B, ruined the part. So for those reasons, I still put this on as an insulator. It's not required to weld. I can weld, you want to see, I'll weld in here without it. Everybody ready? What guys?
And he is welding. Now, is it necessary to actually hold your
I'm doing it because another part's dirty, so I'm trying to keep the...
Oh, sure. But typically you wouldn't even need to cool it or anything. Just
if I
like
had everything clean like I'm supposed to,
yeah.
As soon as I stop, I can move my arm away and you see it would have stayed silver.
And you don't have anything in there.
Right.
I've just done a core prep on these parts to show you the importance of cleanliness here.
Sure, of course.
See, there was a reason behind it.
Yeah. That, and I didn't want to lug my acetone all the way down there, too.
And have that smell in the car.
Yeah.
Right.
But, I mean, it helps in demonstration part. Like, I can sit here and tell you this would happen, but now that you've actually seen it, it can still happen in the chamber if you don't clean your parts. You know, oh, even if I weld in the chamber, I don't have to clean my parts. No, it's still important to clean your parts. That's the one thing with TIG welding is clean, clean, clean. Everything's got to be clean. Your filler rod's got to be clean. You can spend all the time in the world cleaning your base metal. You pick up a dirty filler rod and stick it in there, you'll actually see the dirt coming off the rod into the metal.
Wow.
Especially on aluminum. It'll turn the little black specks and float to the top of the puddle. But no, you don't have to have a cup on in here. You can weld just fine. If it was a perfectly inert atmosphere with clean metal, that would be nice silver weld. I just do it, like if I'm doing a T-joint, now you can actually rest your cup up against and drag it. If I didn't have this, I'd just short out and ruin the part if I touch that on there. So I don't know about you, but I don't like destroying $20,000 and $30,000 parts and a $20-some, gas lens just because I don't want to put the cup on inside here. But
Somebody wouldn't like it.
no. But just to show you, you can do it. You don't need the cup in there at all. It'll weld just fine without it. I could even, if I wanted to, turn the gas off to the torch and weld without the gas inside here. So I wouldn't even need the gas in there from the torch itself.
They don't have any one way made, or they made gas burning.
Right, yeah, big gas fault.
You cut the line and everything. Just to show it.
Oh, wow.